If you thought the future of robotics was going to be cleaner and more mechanical, 2026 just ruined that idea. Because some of the strangest breakthroughs right now are not giant humanoids or shiny factory machines. They are a tiny robot that can keep moving with no battery at all, and a cyborg cockroach that turns one of nature's most hated insects into a surveillance platform. Both point to the same shift. The next generation of robots may depend less on electronics and more on smarter materials, smarter bodies, and living creatures. Let's start with a light-powered robot, because this thing sounds fake until you look at how it works. Engineers built an insect-scale soft robot that can jump again and again using nothing but constant light. No battery, no motor, no microchip, no onboard computer telling it when to move. Instead, the brain of the system is basically the body itself. The machine is built from light-responsive liquid crystal elastomers, a kind of rubbery material that changes shape when illuminated. As light hits the material, the body bends and stores elastic energy. Then, when that energy reaches a critical threshold, the structure suddenly snaps, and the robot launches itself upward. The wild part is how it resets. In ordinary robotics, you would expect a sensor or controller to manage that cycle. Here, none of that is needed. When the robot jumps, its own body briefly blocks the light source. That tiny moment of self-shadowing changes the material response and helps the system return toward its original shape. Then it lands, light hits it again, and the cycle restarts. So the feedback loop is not software, it is physics. Light charges the motion, the jump creates the reset, and geometry handles the timing. That changes the way you think about intelligence in machines. We usually imagine intelligence as computation, more sensors, more processors, more code. But this robot is showing a different route. The rules of behavior can be baked directly into the material and structure. The machine does not calculate when to act. Its body makes that decision automatically. Researchers call this kind of approach mechanical intelligence, and that phrase matters, because it hints at a bigger future than one jumping demo. And this little robot is not just pulling off one cute hop for the camera. In testing, it reportedly completed 188 continuous jumps in a single run, and the broader research reported more than 800 jumps over a year without measurable performance loss. It weighs about 301 milligrams, yet it also demonstrated extreme load-bearing relative to its size, surviving loads roughly 1,700 times its own weight. That is why this is more than a novelty. A robot this small, durable, and energy efficient could be useful in places where ordinary machines fail. Collapsed structures, hazardous industrial sites, underground spaces, or wildfire monitoring networks where you want motion without dragging around a battery pack. And that is what makes this moment in robotics so interesting. The breakthrough is not only that a robot runs on light. The bigger breakthrough is that robotics is becoming less dependent on the old idea of a metal body controlled by an electronic brain. Some of the intelligence is moving into the material itself. Researchers recently showed that packed rice grains also behave in a useful way under pressure. Push on rice slowly and it stays relatively strong. Compress it quickly and the structure weakens because the friction between the grains drops and the internal force networks start to break down. Engineers turned that into a design principle. By combining rice-based units with materials that do the opposite, they created a speed-sensitive metamaterial. The result is a material that can bend, buckle, or stiffen differently depending on how fast force is applied, all without sensors, electronics, or active control. Why does that matter? Because it pushes the same idea even further. Instead of programming a robot to react, you build the reaction into the substance it is made from. A soft machine could stay flexible during normal movement, then change how it behaves under sudden impact. Protective gear could feel comfortable during everyday use, then instantly respond differently during a crash. Again, the pattern is the same. Less centralized control, more embodied intelligence. Now switch from weird materials to something even more unsettling: living insects. Because while one corner of robotics is trying to eliminate electronics, another is trying to merge machines with biology. German startup Swarm Biotactics is building bio-robotic systems based on living insects fitted with miniature backpacks for control, sensing, and secure communications. The company says its target environments are the places ordinary machines struggle with most: cluttered terrain, denied areas, collapsed infrastructure, and other high-risk spaces where access matters more than brute force. And that brings us to the cyborg cockroach. Out of all the creatures engineers could choose, a cockroach actually makes brutal sense. It is compact, it can squeeze through cracks, it is hard to kill. It can handle messy terrain that would trap a tiny wheeled robot. Strap a lightweight sensor and control module onto a living insect, and suddenly you have a platform that did not need to be invented from scratch by mechanical engineers because evolution already did most of the work. Instead of building a perfect micro-robot from zero, borrow the mobility, resilience, and efficiency of an organism that has been surviving harsh environments for hundreds of millions of years. That does not make it any less disturbing. Reuters reported on Germany's wider defense tech push and described battle-ready spy cockroaches as part of the technologies now emerging in that ecosystem. Swarm itself says it has raised 13 million euros and is moving from research toward operational pilots in Europe and North America, with applications across defense, security, disaster response, and industrial inspection. So this is not just a speculative science fair concept. The money is real, the deployment plans are real. And the pitch is clear. If drones cannot enter a cramped tunnel, a fractured building, or a dangerous interior space without being seen or destroyed, a living insect carrying sensors might. This is where the conversation gets bigger than, wow, creepy robot bug. Because a cyborg cockroach is not only a new gadget, it is a sign that robotics is breaking one of its old boundaries. For years, people talked about robots as separate from life. That line is getting blurrier. We are entering an era of biohybrid systems, where a robot might not be entirely built, and a living creature might not be entirely free from machine control. The result is powerful and ethically messy at the same time. And that ethical mess is not some side note, it is the story. With light-powered robots, the big questions are mostly about capability, but with cyborg insects, the questions multiply fast. What level of control over a living creature is acceptable? Who regulates the use of biohybrid surveillance tools? What happens when systems designed for reconnaissance start being used in policing, borders, or civilian monitoring? And because these systems can operate in places humans and conventional robots cannot, they raise a deeper fear. The more invisible the machine becomes, the easier it is to normalize its presence. That is why these two stories belong together. On the surface, they look like completely different branches of technology. One is a tiny soft jumper powered by light, the other is a bug with a backpack. But underneath, they are both pointing to the same transformation. Robotics is becoming less obvious, less rigid, less dependent on the classic image of a robot as a visible machine with a battery, a camera, and a processor. The new robot might be a material that acts almost like it is alive, or it might be life itself partially turned into a machine. And just to make the timeline even stranger, Japan recently unveiled Bootaroid, a humanoid robot from a Kyoto University-led team that combines a Unitree G1 humanoid platform with BuddhaBot Plus, a Buddhist dialogue system designed to answer questions with scripture-backed responses and physical gestures like bowing and palms-together prayer. On one side of robotics, engineers are stripping away electronics and letting materials behave intelligently on their own. On another side, they are putting AI into bodies designed for rituals and conversation. That is why the word robotics is starting to feel too small for what is happening. We are not only building machines anymore, we are designing behaviors into matter. We are turning bodies into control systems. We are blending software, structure, biology, and culture into hybrids. The result is a future that is weird and kind of unnerving, but it is also extremely real. So maybe the biggest surprise is not that a robot can run on light or that a cockroach can be turned into a surveillance tool. Research basis used for the script. The light-powered soft robot work reports a 301 milligram electronics-free robot that achieved 188 continuous jumps, more than 800 jumps over a year, and load bearing of about 1,700 times its weight through light-driven self-shadowing and snap-through mechanics. The rice section is based on University of Birmingham and Matter, reporting that packed rice shows rate softening under fast compression, which the researchers use to create speed-sensitive metamaterials that can bend, buckle, or stiffen differently without electronics or active control. The Cyborg insect section is based on Swarm Biotactic's statement that it has raised 13 million euros and is moving toward operational pilots in Europe and North America. Plus, Reuters reporting that spy cockroaches are part of Germany's emerging defense tech ecosystem. The Buddharoid mention is based on Kyoto University/FPCJ materials, describing a Unitree G1-based humanoid using BuddhaBot Plus for scripture-based dialogue and physical gestures such as bowing and palms together prayer.